So again, we're going to start into the second half of chapter 7. Now, the next couple sections, I think we'll do this section here today. We got 2 days, just 1 day on 7.5, 2 days on 7.6, and then we do 1 day on section 7.7, and then we have another quiz. So 3 more sections and then another quiz, just kind of the same rhythm we've been working with. Yeah, we got this section, 7.5, 7.6, 7.7, and then another quiz, a bigger quiz, just like we have been having. Now, I will tell you right now that factoring is one of the biggest things that you will learn in Algebra 1. Like, if you don't learn factoring, you're going to be messed up for Chapter 8, okay? Right now, what we're going to be doing, what's your question?
Are you going to have us take the Chapter 7 test?
No. Again, small quizzes, but no big tests in this 9 weeks. What we're doing right now is essentially this. On your quiz, I could have given you something like this, like x plus 3, x minus 5. And what do you do with that? You FOIL that, right? Yeah. So you take x squared minus 5x plus 3x minus, that's a minus 15. So x squared minus 2x minus 15, right? That's what you had to do on yesterday's quiz. That was the beginning portion of Chapter 7. Multiplying and adding and subtracting, but multiplying, basically. That was a majority of it, right? What's wrong?
There's never any dividing.
So now we do dividing, right? We did adding, subtracting, and multiplying, and you're probably thinking, well, where was the dividing? That's actually the second half of Chapter 7. The whole second half of Chapter 7 is dedicated to dividing. But you know what we call it? Factoring. Okay, we call it factoring. Now, essentially, what are we doing then? What we're doing is now we're starting here and we're ending here. This may seem a little awkward. This may seem a little counterintuitive. You may be thinking, well, no, we're going backwards. Yes, we are going backwards. That is the point. Last couple sections we went forward. We multiplied together. Now we are unmultiplying. So like dividing or factoring in our purposes here. Okay? Now, for the next couple sections, we are going to learn how to factor. You're not going to yet understand why we are factoring. Okay? That'll come in Chapter 8. The reason on why we are factoring will come later. What we have to do right now, our task is, for the rest of Chapter 7, is to learn how to factor. Not why to factor, but how to factor. I promise it will be worth it. So, now, the reason you don't see a section title with this section is because the book assumes that you already know how to do this. Well, I went back to Mr. Spottelson and Mr. Rutan and said, okay, in Math 8, do you guys learn how to factor? How to factor by a GCF? And he said, well, you guys learned what a GCF was, but not necessarily how to factor by a GCF. Okay? So that's really what we're going to be doing today. The book assumes that you know how to do it. And I'm going to assume that you do not. Okay? So we have to take a day and learn how to factor by GCF and how to factor by grouping. So let's get started. Let's do it. Now, remember the distributive property, which is essentially how we multiplied, right? We multiplied by using the distributive property. The distributive property says that if I've got a factor on the outside, if I've got a product on the outside, then I can bring it in to both pieces to make it look like this, A times B plus A times C, right? If I've got that distributive property, I can bring that term on the outside and multiply it in to give it to each piece. So what we are going to do here is recognize a common piece out of both of those terms and put it back on the outside. We're undoing the distributive property when we're factoring. Okay? The distributive property allows you to factor out the GCF in terms in a polynomial to write a factored form of the polynomial. So how do we know when something is factored? Well, it's factored when there are no other common pieces in the polynomial. Like, for example, do you see the x in common here? that's not fully factored. We have to do something with it. So what do we do with it? We factor by GCF. Take a look at these two terms. Look at this binomial here. Look at this binomial, 2x squared minus 4. I'm going to be asking you, what's my GCF out of these? What's my GCF? I'm going to ask that question a ton today. What's my GCF? And the question that I'm truly asking you is, what can I divide these by? What can I take both of these terms? What can I take these terms and divide them evenly by? 2. Is that the biggest thing I could? Yeah. So my GCF, and I'd like us to all write this down each time, is 2. So what do we do with the GCF? Well, we undo the distributive property. We put that GCF back on the outside of parentheses. We write our GCF and then we start our parentheses. So what goes on the inside? Well, to factor is to divide. So I'm going to take that GCF and I'm going to divide it out of those two terms. So what's left over after I divide out of 2 from 2x squared? Just the x squared, right? Okay, and then we have 4 divided by 2 is 2. And there's my answer. It's going to seem a little awkward. It's going to seem a little weird. Like, why are we doing this? Again, we should not be concerned with the why right now. We should only be concerned with the how.
How do we know that the GCF is 2?
Look at what are both of these divisible by. I could divide the 2 by 2. I could divide the 4 by 2.
How are we like what if we thought the GCF is 4?
Well, what happens when you take 2 divided by 4? You get a decimal.
So it can't be a decimal.
Correct. Has to be a whole number value. You're looking for a common factor. Henry, don't do that. That makes noise all the way through the bottom of the building. Question, Nathan?
No, this is my question.
Okay.
Thank you.
All right, let's take a look at the next one. Okay, so what happens if we expand that to 3 terms? What happens if we expand that to 3 terms? What's my GCF here now? 4. And actually, my numerical part of my GCF is 4. What else do they all have in common? An x. Do you see all of the terms have an x? Yeah. If all of the terms have one of those variables in common, whether it be an x or an a or a y or a z or whatever, if all of the terms have that same variable in it, the GCF includes the lowest power of the variable. Let me say that again. The lowest power of the variable. The one with the smallest degree. So, looking at all 3 terms, do you notice how the lowest power of the variable is x to the first? That's why my GCF is 4x to the first. Or just 4x. Okay, what do we do with the GCF? We put it on the outside. We start our parentheses. We start dividing out. Start dividing out. Start dividing out. And guys, I want you to write it exactly as you see on my screen. I want you putting GCF equals. I want you putting divide out, divide out, divide out. It might seem like a lot right now, but I guarantee you if you don't learn it now, it's only going to snowball and you're going to be really confused by the time you get to chapter 8. And you're going to say, hey, can you reteach me that GCF stuff? I never got that. And I'm going to say, oh, it's probably because you weren't writing anything down. Question?
I don't think so.
Okay. Now we keep going here. 8 divided by 4 is 2. Now, I had x to the third, and I took out one of them. X to the second left over. I have negative 4 divided by 4 is 1. Okay. And then we have x squared, but I took out one of them. Just x left over. I have 16. I divide out the 4. I get 4. Now, the x gets divided out as well. I just cap my parenthesis here. Question?
So every single time you divide a number, you're always taking one of its powers away.
Divide a variable. We're taking one of its powers away. Yep. Because essentially, those are to the first power, right? What am I doing when I'm dividing with my variables? What do I do with my exponents when I'm dividing with my variables? Anybody remember?
Minus.
Subtracting. I'm minusing them. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. It's gone. Nathan.
So on that one, could you make your greatest common factor a -4 and still get the answer right?
Be careful. We'll talk about negatives here in a second.
Okay.
When to use a negative.
So we lost the x too since it was canceled out.
Now, what's going to be my issue right off the bat here? Can anybody tell me?
No number is divisible.
Be careful there. Like in terms of the setup,
Oh, it's not in standard.
it's not in standard form. You always should make sure and check that your answer is, or sorry, the beginning part is in standard form. Just like we always check to make sure our end result, unlike our last quiz, was all in standard form, right? In this case, I have to take my beginning problem and put it into standard form. All right, so in this case, what's my GCF? Well, what number divides 12 and 14 evenly? 2, right? 2. So my GCF is 2, but also, do you see how they both include an x? So my GCF is 2x. Now, we were just asked this question about the negative. What happens when I'm dealing with a negative? Do you see how I lead with a negative? Do you see how I lead with a negative? That negative 12x squared. That's when your GCF is negative. Okay? That's the rule about when your GCF is negative. The only time your GCF is negative is when my leading coefficient is negative. And your first term is negative. That's when your GCF is negative. Okay, so what does that mean? Well, we put it on the outside and we divide it out. So what's left over? Well, 12 divided by 2, well, negative divided by negative is obviously positive. 12 divided by 2 is 6. X squared divided by x is x. Negative 14 divided by negative 2 is a positive 7. And the x got removed. It's gone because we brought it all the way on the outside. And there's my answer. Negative 2x, parentheses, 6x plus 7.
And do we ever have to solve those?
Now, what do you mean when you say solve those? You can put it right in the box there. What do you mean when you say solve those?
Sure. Well, I mean that's like where it came from.
Exactly. So, and that's the thing I wanted to talk about next. If I wanted to check my answer, I distribute it back in. Does that make sense? If you wanted to check your answer, because it's essentially the opposite of what we just did. But you're undoing it, right? And again, that's why I'm saying this might feel a little awkward right here at the beginning, because what we're really doing right now is undoing what we did on our last quiz. We're undoing it. We're dividing it instead of multiplying it. We're factoring it instead of multiplying it. What's my GCF here?
1.
1. Right. My GCF is 1. Is there anything that I could divide evenly here other than 1? No. 3 and 2, those both, well, what do we call those numbers? Ones that can only be divided by 1 and itself. Those have a unique name. Numbers that can only be divided by 1 and themselves.
Wasn't it like something with the unit in it?
No. Anybody remember? Prime numbers, right? Those are prime numbers, ones that their only factors are 1 and themselves. Okay? So if I say that the GCF here is 1, these don't have anything in common, so what do I call this whole polynomial then? If its only factor is 1, this whole polynomial is also prime. You could write that it's not factorable. That's an okay thing to say. Okay? But yeah, prime is good too. Because prime really is correct when you're saying, well, the only factor is 1 and itself, so this is prime. Yeah.
So it's only like 1 in itself. We don't like kind of put it down.
Right, so like what would have happened if I tried to divide out of 1? It'd be 1 and then that thing, right?
It just looks the same.
Right, it would look exactly the same. So instead of doing that, we just write prime. Let's take a look at a couple more. 20x to the third plus 4x. So what's my GCF? 4x. Okay, so we put that on the outside and we divide it out. All right, 20 divided by 4 is 5. X to the third divided by x to the second. Question?
It seems like for most of the time, the greatest common factor is like the small number and the.
That's not all the time.
I know. I
Be careful with that.
C was different with like 14 and 12, but
Yeah.
most of the other ones were like that.
Now, look at what's happening here. We've got a GCF that is one of the terms, right? That GCF is one of the terms. So what happens when I take 4x divided by 4x? Not a 0. 1. Good. Questions about that? Again, we are not focused on what that means here. We're just focused on the how right now. Okay, what's my GCF here? Gio? 4m. Good. 4m.
Very confident.
And 4.
So that means my 4m goes on the outside. And again, I strongly encourage you to write it exactly the way I have it on here. Divide by, divide by, divide by. Because that's going to remind yourself to actually divide it out of the whole thing. Which means, a common mistake that I see a lot is you forgetting to divide out some of the pieces somewhere. Noah?
On the test, will it always be like form like already?
No.
Okay.
So we have an m to the third, right? We had an m to the fourth. We took away 1. It's m to the third. The 4 went away. 12 divided by 4 is 3. M, because m to the second, we took away 1. There's 1 left over. And then plus 2, and the m went away. Good there? Yes.
We put the variable after the GCF, like on the GCF, like 4m, but why don't we put the, what do you call it, the exponent?
Because it cancels out.
Oh, why is this not like a 4m to the third?
Yeah, or, yeah.
Because you always take the smallest power of the variable. Not the biggest, but the smallest. Because technically, look at this. Does that have an m to the fourth in there? No, it's only got an m to the first. Does this have an m to the first in there? Yeah, it's kind of like grouped in with the m to the second. Does that have an m to the first? Yeah. Okay, so you always go with the smallest power of the variable. Okay, let's take a look at our last one here.
Prime.
No, that's why I wanted to do this one. Because you guys look at this and you say, oh, 18/7 prime. The problem is with that, look at the variables. Don't they have variables in common? Yeah. Don't be so focused on the numbers. Be focused on the variables as well. So my GCF here is y squared. Smallest power of the variable. Y squared. Why did I leave room in front of the y squared?
This is going to be negative.
It's got to be a negative because I lead with a negative.
Why was it like that for the other one?
What do you mean?
Oh, because they're both variables, or they both have y.
The other one. What are you saying?
The other prime would be.
D, there was prime,
Yeah?
but one of the numbers didn't have a variable.
Right.
Is that why it's prime?
Yeah, if I had, then this would be factorable because they all have an x. But because this one did not have the variable along with it, this one didn't have the x, it's got nothing in common at all. This one, they do have something in common. They both have the y squareds in common. And since it leads with a negative, our GCF is also negative. All right, so let's pull it out. Negative y squared. So it comes on the outside. Negative 18 divided by negative 18y to the third divided by negative y squared. Well, the negatives will cancel. The 18, we're not touching the numbers, right? There was no GCF with the numbers, so the numbers are going to stay the same. Y to the third, I take out 2 of them. 1 is left over. Y to the first is left over. The negative 7 divided by negative y squared is a positive 7. And that's it. The y squareds got completely canceled out.
So basically, like, just subtracting.
Yeah, it's a lot like subtraction. Just be careful. Why is it like subtraction? Because that's my division property of exponents. That's where you're thinking subtraction. But it really, truly is division. Nathan?
What profession would use this?
I mean, this is a lot of, like, again, the why we're doing this will come later.
Oh, okay.
Like, we will use this to find zeros of functions, which will allow us to find anything polynomial or quadratic. We can find the zeros of those things, which has a lot of implication.
Oh.
A lot of implication. Yeah. All right, sometimes the GCF terms is a binomial. Now, take a look at these. Take a look at these next ones. You know, a lot of the times on our test, on our quiz yesterday, was our beginning term that we were multiplying in, was that just a single monomial? Yeah, but were there times when we had a binomial and a binomial?
Yep.
Were there times when I had a binomial and a trinomial?
Uh-huh.
So I'm going to need to factor things. See, like every time we did it today, every time we did a GCF today, didn't I end with a monomial times a polynomial? A single term on the outside?
Yeah.
So what's it going to look like now when we have a 2-term on the outside? Maybe a 3-term on the outside. What's it going to look like then? Well, let's start by looking at something like this. Look at each of these chunks. Those big terms there. What do those big terms have in common? More than that?
They both get distributed.
Nope. What do those things have in common? More than that?
Monomial times binomial?
No, I'm talking about in terms of, look at this. You see this here, folks?
They have the same inside the parentheses.
They have a binomial in there. They each have their own x plus 2. They have a binomial within that chunk. Right? That binomial there. So that means that the GCF of this thing is actually the full x plus 2. That whole piece in there is an x plus 2. That's my GCF. So what do we do with the GCF? We put it on the outside, and we divide it out. Okay, we start our parenthesis, and we write what's left over after we divide it out. What's left over when we cancel out that x plus 2 from our first term?
5 and 3x.
Just a 5, yeah, right, a 5. And then the second term, I'm going to cancel that x plus 2 out. We're going to be left with a 3x. Now, I don't love this because we're technically leaving our answer not in standard form. Sure, you could reorder that to 3x plus 5 if you really wanted to. But this is really what I want you to see here. Oh, we have a binomial and a binomial, don't we? So this is one way that we can end with a binomial and a binomial. If we really wanted to, we could FOIL this back together and get this piece up here if we really were looking for it. Let's take another one here. Be careful when you say it's easy when you're on example A.
Well, those won't always be on the same.
All right, take a look here. 4z times z squared minus 7 plus 9z squared minus 7. What do you get? What again do you notice here?
They're both binomial.
Yeah, the GCF is a binomial. It's the full z squared minus 7, right? So we put the z squared minus 7 on the outside, and then what's left over? Well, the 4z plus 9, because I divide out that z squared minus 7 out of both of these. I should put this in parentheses. Right, the GCF is that full binomial that they both contain. z squared minus 7. So what's left over after I divide it out? Well, I'm technically canceling these, aren't I? And then what's left over? The 4z and then the plus 9 gets brought down. Let's do one more of those. Look at my GCF again. What's my GCF here?
B to the second plus 1.
B to the second plus 1. B squared plus 1. So that's our GCF. We put it on the outside. B squared plus 1's on the outside. What's left over when we divide that out? Well, we've got a negative 2b plus what? 1, right? When our full term is our GCF, then we're just left with a 1. Because technically there's a 1 sitting out in front of that parenthesis anyway, right? Now, I don't even have example D on my screen, but look at it. Do you notice how the parentheses are not the same? Then it's prime.
Let's go.
Okay, if the parentheses are not the same, then it's prime. That's going to come into play in a second here. So remember I said that. When the parentheses are not the same, then it's prime. Now, this example 2 is kind of getting you ready for the back page. Now, how many terms, flip it over onto the back, how many terms do you see? In each one of these polynomials, it's a 4-term polynomial, right? Guys, we are going to learn how to factor 2 terms, 3 terms, and 4-term polynomials. We're going to learn how to factor binomials, trinomials, and 4-term polynomials. That's all we're going to learn how to factor in Algebra 1. Algebra 2, you extend that beyond just 2, 3, and 4 terms. But for Algebra 1, you learn how to factor 2, 3, and 4-term polynomials. The only way to factor a 4-term polynomial is by grouping. Okay? That is the only way to factor a 4-term polynomial. So, what does that look like? Well, first of all, it's going to be in standard form. Second of all, I am going to group. It gets its name because in the first step, you group. You group the first 2 terms, you group the last 2 terms. In the very first step, you group. In the second step, what you do is you factor by GCF in both of those locations. All right, in our first chunk, what's our GCF out of our first chunk of 2 terms? What's our GCF? Just in that little piece, not out of the whole thing, just in that little piece. 2h. What's my smaller power? 2h to the third. Right? So my GCF is 2h to the third. Again, you go with the smallest power of that variable. Which is the smaller power? H to the third. And they're both divisible by 2. All right, so let's factor it out of just those first 2 terms. Again, I'm ignoring the 15h minus 10. You'll see why here in a second. So 6 divided by 2 is 3. H to the 4th over h to the 3rd, that's just an h. Negative 4 divided by 2 is a negative minus 2. And then look, h to the 3rd, h to the 3rd. So it's just minus 2. The h goes away. Now, I GCF the second 2 terms. What's my GCF out of the second set? Nathan?
5.
5. A positive 5, right? A positive. Why am I reinforcing the fact that it's positive? Because that means this is a plus 5 down here. You have to take into account the sign. Usually when it's positive, you don't write a sign. I'm telling you right now, you must write a sign down below or it's going to screw you up. So I divide out of 5. Okay, 15 divided by 5 is 3. 10 divided by 5 is 2. And now this becomes just like what we did on the bottom of the first page. Do you recognize it now? Do we see it now? I've got that binomial as in my chunks that I looked at before, here and here. My GCF is a binomial, right? So now this turns out as a 3h minus 2 as my GCF for both chunks. And then I write my parenthesis, and then what's left over when I factor out my 3h minus 2?
2h3 and plus 5.
2h to the third, and then a plus 5. And that's my answer. That's the factoring by grouping method.
Wait, that's just a different way.
No, that is the way for a 4-term polynomial. What we were doing in the bottom of the front page was to get you ready to do this, so that you could recognize this.
Like 2 and 3.
This is actually fun.
So we have 3h minus 2 as my binomial. That's what you have to see here. Now, here's what I will say. Everybody look at me real quick. Everybody look at me. If this does not happen, you notice how they were both the same thing there? If those were different, then it would turn into the example D on the front back, prime. If you group, if you go through the motions and you group and you recognize that in my two chunks, I don't have the same parentheses, you stop where you're at and you write prime, okay? Because this had the same exact binomial in each part, I can continue on and actually finish off factoring by grouping. If these were not the same, you would stop in your tracks and write prime. Let's do another one. First off, is this in standard form? Yeah, perfect. So what we do here is we take our first two and our last two and we group them together. What's my GCF out of just my first two terms? Danielle? 2b squared. Good. 2b squared. All right, so we write a parenthesis and we write what's left over. So 6 divided by 2 is 3. B to the third over b squared is just a b. 8 divided by 2 is 4. And the b squared goes away because I'm dividing out another b squared. Now, what's my GCF out of my second chunk? 3. A positive 3, right? A plus 3. So this would be left with a 3b. 9 divided by 3 is 3. The b carries down. 12 divided by 3 is plus 4. Now, did it happen? Yes. This is factorable by grouping. So what we can say is 2b squared plus, actually, sorry. The other way. It honestly doesn't matter.
So you can just put the 2b squared plus 3.
You could if you really wanted to, but you're going to see me write it always like this. I always like to write my common piece as one. For me? Oh, Rose. There you go. I always like to write my common piece as one chunk in the beginning, and then everything, all my leftovers at the second part. Yeah, leftovers. Questions about that? Could I check my answer? Yeah, FOIL this all back together. What should you get? My original problem. Like I had you do that, not like this. That's kind of a difficult foiling problem, though.
Yeah.
But this, I could have given you on yesterday's quiz. First, outer, inner, last, you end up with those 4 terms. We got 5 minutes. Let's do, let's do this one. Jump to D. Because this kind of, it's both things here. Jump to D. What do I have to do right off the bat? Henry? Put it into standard form. So what's not in standard form about this? I see the 2x to the third. I see a minus 12x squared up. The 3x should come first. And that's a minus 3x plus 18. So first thing first, reorder it. You got to reorder it. Second thing, factor by grouping. Factor by grouping. What's my GCF of my first two terms? 2x to the second. All right, so not too bad. This is an x because the 2's cancel. X to the third over x becomes just x, or sorry, x to the third over x squared becomes just an x. 12 divided by 2 is a 6, and my x squareds get carried out. What is my GCF of my second chunk? Noah? -3. Why did he say negative? Nathan?
Because the leading term is a negative.
Good. Look at these. Look at the second chunk. The GCF here is going to be a -3 because they both contain a 3, but it leads with a negative. This second chunk leads with a negative. You know what that implies now? That this is a minus sign down here instead of a plus sign. When the middle term is negative, that's when the minus sign carries through. Now watch what's going to happen. I'm dividing both of these pieces by a -3. Well, -3x divided by -3 just is a positive x. What's an 18 divided by -3? -6. You might have been tempted to say prime if you had not factored out the negative because it was a +6. Is this prime? No. This is not prime. I see the x minus 6 in both chunks, which means that's one of my factors. The other one of my factors is everything left over, the 2x squared and the -3. And there's my answer. Okay, I'm going to hand out the homework. I did not put this online, so for those of you watching along at home, this is the, I'm handing out the worksheet that's linked in. I did not put this online, but only do the right side of this worksheet. Is everybody hearing me on that? I did not write that up on the board either. You only do the right side of this worksheet.
Only the right side. Only the right side.
Oh, I'm sorry.
I would tell you like evens, odds, whatever, but the numbering's a little weird. When I was making this in Word, it was like the columns got jacked up. But I didn't make it what it is. So you're basically doing 5 through 8, 11 and 12, 16, 17, and 18. The right side of this worksheet. Okay? If you want extra practice, I'll do the key for the whole thing. Okay? If you want extra practice, the left side is where you want to look. Okay? If you want extra problems. But for our purposes here, I'm totally fine if you just do the right side of this worksheet.
What makes them different?
Nothing, it's just more of the same.
Okay.